Section 1.4, approximate linear relationships. This section is very, very similar to section 1.3. In section 1.3, we were given data and we plotted it and we found that we had a perfect line, basically. Our data fell into a perfect line. In this section, we're going to graph our scatter plot. We're going to look at our data, and we're going to see that it comes very close to being a straight line. It's not exactly a straight line, but that's okay. That's the way things are in real life generally. When you have data, very rarely does it fit perfectly into some sort of curve, some sort of line. You estimate it, and that's what we're going to do here. All right, before we get to that, we do have a couple new definitions that we're going to see in this section. The first one is called interpolation. And we perform interpolation when we use a part of the model whose t-coordinates are between the t-coordinates of two data points. Basically, when you're estimating, you're doing interpolation when you are within your data points. Conversely, we perform extrapolation when we use a part of the model whose t-coordinates are not between any two data points. So when you're outside of your data and you're using your model to make an estimation, you're extrapolating. And our other definition is when a model gives a prediction that does not make sense or an estimation that is not a good approximation, we say that model breakdown has occurred. And we kind of saw that back in section 1.3 a little bit. We had a graph and we talked about where a car had no value. And I said, you know, that really doesn't make sense. A car would generally always have some sort of value. And that would be model breakdown. All right, so let's try a problem here. Let me see if I can find a good one in the book. All right, I got problem number 16 on page 45. And it says, let's say you have a 10-mile-an-hour wind, and you go and check the temperature. And you'll see this on the news all the time. Given the temperature, they'll also give you a wind chill temperature. So if the temperature is really negative 15 degrees, but you have a 10-mile-an-hour wind, it's going to feel like negative 35 degrees when you go outside. And similarly, if the temperature is, say, 15 degrees and you have a 10-mile-an-hour wind, then the temperature on your skin is going to feel like it's 3 degrees. All right, so what we're going to do, we're going to graph this data, and we're going to make an estimation of a model. This data is a little bit different in the sense that I have positive and negative values. That's okay. I know how to graph when I have positive and negative values. Draw my grid like so. Now let's see here. On the x-axis, I have temperature. And on the y-axis, I have wind chill. Looks like going by 5s will work nicely on my x-axis. 5, 10, 15, 20, 25, and I also need some negatives. Negative 5, negative 10, negative 15. And as usual, you don't have to label all of them, just enough so we know what's going on. My wind chill axis, my y-axis, I gotta go as low as negative 35, as high as 15. Again, I think 5s would probably work all right. 5, 10, 15, 20, 25, 30, 35. And then this way, 5, 10, 15, 20. So 10, 20, negative 10, negative 20, negative 30. All right, when you draw a graph on your test, this is the minimal stuff I expect to see. You need to draw the axes. You need to write your units, temperature and wind chill, and then you need to give me a scaling, like I've done here. All right, now we plot our data. Negative 15, negative 35. Negative 10, negative 28. Got to estimate on that one a little bit. It doesn't fall right on a spot that I marked. That's okay. Negative 5, negative 22. 5, negative 10. Oops, that's the wrong spot. 5, negative 10 should be right here. 10, negative 4. 15, 3. 29. And 25, 15. and we're ignoring the one spot there that was bad. All right, so you see that our data falls closely into a line, but maybe not exactly. But what we do is we take a ruler and we try to draw a line that kind of averages out the data spots. So I might draw a line like so. So you notice the line is a little low on some data spots down here, a little high on some data spots down there, but it's kind of in the middle, and that's kind of what you want there. All right, now the book gives a couple questions, and I'm skipping those questions. I'm going to kind of make up my own questions here. All right, so part A. I'm going to ask you, what if the temperature is, say, 0 degrees? What's the wind chill? Well, I look at my model, and I notice that's actually an important spot. That happens to be one of the intercepts right there. It looks like if my temperature is 0, my wind chill is about, oh, let's see, I think I would go with negative 14 degrees. So I could have also asked, what's the wind chill intercept? What's the vertical intercept? And you would have given me the same answer. Is this interpolation or is this extrapolation? Well, notice that my temperature 0 does fall within the data that I have. It's kind of here in the middle. So this would be interpolation. Okay. Question B. What if I ask you, how about if the temperature is, the original temperature is 35 degrees? What's the wind chill temperature? All right, well, I got to go here. It's 25. There would be 30, 35. My temperature's 35. I got to go up here and then across. Looks like my answer, I would say, looks like about 22 degrees. Is that interpolation or is that extrapolation? That one's extrapolation, because this 35 here, this point that I just drew on my line, this new point, is outside of all of my data. So that would be an example of extrapolation. Question C. What is the temperature intercept of my model? Well, let's see. That looks like it's right about here. So it looks like it's 10, 0, which says if temperature is 10 degrees, wind chill is 0 degrees. Which, if you compare that to our data, you'll see that's not quite right. But is it a reasonable answer? Well, I think so. You know, again, this model here was not perfect because the data was not a perfect line. So we do have an estimation. I don't think we have model breakdown here. If I had drawn my line and said my temperature was 10 degrees, my wind chill was 15 degrees, then I would say I have model breakdown. But here, my temperature being 10, my wind chill 0, is pretty close to the true value of temperature being 10, wind chill of being -4. So I think that's okay. Models are estimations. You're not going to get exactly correct answers. That's okay. Also notice that the way I drew my line, you might have drawn your line slightly differently. So your answers for parts A and B might have been slightly different. That's okay. They have to be reasonable answers, but everybody's not going to have the exact same answers in this section.